Hi class, today we're looking at simplifying radical expressions. So let's check out our radical expressions. Here we go. You've done some of this already in your geometry class, but this is great practice for us. So I take a look over here and it says simplify the radical 32. So what I do is I can break this down. There's a couple different ways. I'm going to show you the tree method and then you can look at another method. So first of all, 32. If you divide it by a prime number, and remember your prime numbers are 2, 3, 5, oops, hello, that looks like a 5, there we go, 7 or 11. And this one divides nicely by a 2 because it's even, so I do 2 times 16. Now I can break this down. Now 16 is a perfect square. It is 4 times 4. So remember our little scenario where this is like our little club, and the couples, if you have a couple or a pair, they have to leave the club. So here's a pair of 4s, they have to leave the club. The single, 2, stays in the club. So we have 4 root 2. Let's take a look at this question. Square root of 9x to the third power. So the 9 we can break down to 3 times 3. X to the third can actually be written as x to the first, and first. So if we find a pair, that goes outside the club. And there's another pair. So here's our little club. The 3 goes outside. And a pair of x's, the x goes outside. And what's left is the single x inside. And that's how you could do this. Now, there are other methods. So I wanted to show you the alternative that the book has. So let me just erase this stuff really quickly. And let's reveal what they do. Now what they do is they break it down and they leave 32. They break it down to 16 times 2 all under the radical. They know the square root of 16 is 4. Oh, I'm so sorry. First of all, they write them as 2 separate radicals. And then you can go, oh, what's the square root of 16? It's 4. And the square root of 2 does not turn out to be anything but a decimal, so we leave it as square root of 2. Okay, so this is a second choice. If you'd like to do it that way, you're more than welcome to. This one, they break it down to 9 times x squared times x to the first. And what they do is they break it down even farther, and they take the square root of every term separately. The square root of 9 is 3. Square root of x squared is x. And then the square root of x doesn't work, so we leave it as a square root of x. Now, whichever method works best for you, you can choose. All right, next, I would like you guys to pause your video and try out these two, simplifying the radicals. Welcome back. The square root of 24, if you simplify it, becomes 2 root 6, and the square root of 25x squared simply becomes 5x. All right, let's take a look at the next screen. Now this one is a different kind of simplifying. They give you square root 6 times square root 6. Well, square root 6 times square root 6, you can put them both underneath the radical since they both have radicals. So that is the square root of 36. And you all know your perfect squares. So what is the square root of 36? Voila, it's 6. And by the way, notice here we have a pair of 6's. So wouldn't you just pull it outside the club and their answer would be 6. There you go. All right, so let's take a look at this one down here. We have square root 3x and we have 4 square root x. Now these two square roots information can be combined underneath one radical, and so that's what we do. The 4 that's outside the radical must remain outside the radical. So now we go ahead and multiply. X times x, of course, is x squared. So you have 4 root 3x squared, and now we have to simplify this. Now see how you had a pair of x's here? Yes, you're right. We have to pull that x out. So that's what we do. We have 4x square root 3. Now this is their drawn out version. You're more than welcome to take the shortcut. If you see a pair of x's, pull it out. The square root 3 is a decimal, so leave it underneath the radical, and it's alone. All right. Okay, let's try this one. It's a little bit more challenging. We have all of these terms underneath the radical, and the x under the radical, and 3 is outside. So we're going to rewrite it with 3 out in front and everything else underneath the radical. Now, the square root of 7 is a prime number. It's going to be a decimal, so leave that under. See how you have a pair of x's? We'll pull an x out. See how y squared would be a pair of y's? So pull a y out. So guess what? I'm going to skip right over here. It's 3xy root 7. Now, if you need to see this written out, I'll write it real quickly. Let me grab my pen. So basically, we have 3 square root. I'm going to break this down to 7x, and then y squared is the same thing as y, and then we have our x. So do you see how we have a pair of x's, and that's why I wrote the x outside in a pair of y's? So we write the y outside, and then we have root 7. All right. Here we have a different format. We still have to simplify this. Now, this can be written with a square root can be written on the top, the numerator, and the denominator. So you can break it down like this since they're both underneath the radical. The square root of 13, well, that's a decimal because it's a prime number, so leave it. But the square root of 100, oh, let's see. What is that perfect square? 10 times 10. So let's pull out and write it root 13 over 10. That's a simplified version of that question. All right, let's simplify this one. Square root of 7 over square root x squared. Voila. Square root of 7 does not simplify, so leave it. Oh, x squared, remember that's x times x, which means we have a pair of x's. Pull it outside, so there we go, square root 7 over x. I would like you to try out these 2 questions. Pause your video and give it a try. Welcome back. Let's see how you did. The first answer, the simplified version, is x squared root 2. And this one, the square root of 1 is 1, and the square root of y squared is y, so it's simply 1 over y, and there is no radical. Our last information to learn tonight. All right, we have 5 over root 7. Now, there is this little rule that you cannot leave a radical in the denominator. You can leave it in the numerator, but you cannot leave it in the denominator. So we have to do what's called rationalizing the denominator. And this is what you do. You take, to get rid of this root 7, you multiply by the exact same number. Now, you can't just do it to the bottom. You would have to do it to the top and the bottom, so you're multiplying technically by a 1, which doesn't change the problem, which is great because you're not supposed to just change math problems all of a sudden. So we multiply the numerator and the denominator by a root 7. Now, when you do that, root 7 times root 7 gives you, let me write this out real quick so you can see it better. So we have 5 root 7 on top, and we have root, put them both underneath the radical. Do you see? There's a little times thing. Do you see how there's a pair of 7s here? So now, since you did that, we have 5 root 7 on top, and the pair of 7s goes outside the radical, so we're left with nothing inside, and now this is the final answer. Yes, I know it doesn't look pretty, but that's the answer. All right, let's take a look at another one. Now notice we have a radical in the bottom, so we're going to multiply the top and the bottom by that same exact denominator, root 3b. So what happens? So we have root 3b times root 3b, so that allows us to have 3b in the bottom. Grab my pen. 3b goes in the bottom, and 2 times 3 root b, so we put that all underneath one radical. 2 times 3, that doesn't look like a 3. Oh my goodness. Okay, let's try that again. This is looking horrible. One last chance. Let's try this again. So we have square root of 2 times 3b, and on the bottom we have root 3b times 3b, because we're just combining them under the radical. On the bottom, since these are a pair, we pull out 3b. Now, this part here, we have root 2 times 3 is 6. The numbers can be multiplied, b. Now, there's your final answer. I would like you to pause your video and give these 3 questions a try. Notice the radicals are all in the denominator. You must rationalize the denominator, multiplying numerator and denominator by whatever is in the denominator. Pause your video. Welcome back. Let's see how you did. Okay, 1 over root 3 becomes root 3 over 3. 1 over root x becomes root x over x. And the last one becomes 3 square root 2x over 2x. All right. Hope you guys learned a lot tonight, and I will see you tomorrow.